Okay, to do a problem like number 11, the first thing I would notice is that we have a circle. And so circles, we always have radii. So I'm keeping that in the back of my head. We have circle O, and that's given. I also notice that angle 1 is congruent to angle 2, and that's also given. So I'm trying to get this to be perpendicular with WX. So to make right angles, we need the angles to be supplementary and congruent. So I'm going to put little numbers in here so I can refer to them. So I need angle 3 to be sup to angle 4, which it is, and I need angle 3 to be congruent to angle 4. So that's what I'm going to try to get to, is to get those to be congruent to each other. So let's go ahead and, I can go equidistance as well. Okay, so let's just do this way. So because angle 1 is equal to angle 2, I know that XY is congruent to WY, and my reason would be if angles are congruent, then the corresponding sides have to be congruent. So I know this side has to be equal to this side. I know that ZY is congruent to ZY, and that is the reflexive property. Okay, ZY is congruent to ZY. I know that I'm going to use some OX is congruent to OW, and that is all radii are congruent. So this is congruent to this. And then I can say that OY is the perpendicular bisector of WX. And that's if 2 points are equidistant from the endpoints of a segment, then it is the perpendicular bisector of the segment. So I actually went the complete wrong way. I wanted to get angle 3 congruent to angle 4, which I did not get. I still proved that it was perpendicular. Yes, I proved it was the perpendicular bisector, but I still proved that it was perpendicular, which means I'm done. I did not need that, let's see. I did not need this reflexive property one. And that's it, actually, because statement 3 and statement 5 proved it's a perpendicular bisector. And so I would be finished.